Okay folks, here we have the tools that we'll be using for the experiment. Just to make everything equal, I've got an instant read thermometer or temperature gauge. So I'm going to fire up on the water. So that water is about 21 degrees Celsius, which is probably about 68 degrees Fahrenheit. So room temperature roughly. The pot, again, it's 21 and a half degrees roughly. The temperature of the surface, about 21 also. So, I don't know how to get the Fahrenheit. I don't know why this is not Fahrenheit. I forgot. So we've got a glass here. And again, it's normal temperature. Nothing shady, nothing's been reheated, nothing's been changed. So I'm going to take 2 cups of water. Put it into the pot. The other 2 cups. Alright, so this is the test to see how fast induction cooking is versus regular radiant heat. So, I am going to turn on the unit. Oops, pause. So just before we begin, I will plop down a timer to see how long it takes to boil the water. Zoom in. No funny stuff here, guys. No funny stuff. So I'll just zoom back out. I'll start the unit. And I'll start. And we're at boiling. So let's see how long it takes to boil 2 cups. Oh, sorry. Is this 2 cups? Sorry, 4 cups or 1 liter of water. Now, just to let you know, that water's not boiled yet. I'll zoom in so you can see it. Just as a quick idea, so out here, this temperature is about 23 degrees on the glass. It is super cold. I can't feel anything. Into the pot itself, we're climbing it to 40 degrees Celsius, which is, I don't know what 40 degrees is, but it's 40 degrees. And it's been a minute. Let's do that every minute to find out what temperature it climbs to. There's no trickery. This is just the water I poured into here. Temperature's going pretty good. It's been a minute and a half. This has been a minute and a half. And you see some bubbles already starting to form at the bottom. Actually, I might be able to just leave it up here as well. Let's run the gun here. It's almost been 2 minutes. We're almost 60 degrees. Yeah, just about 55 degrees Celsius. I wish I knew what that is in Fahrenheit. Okay, Google, what is 55 degrees Celsius in Fahrenheit?
55 degrees Celsius is equal to 131 degrees Fahrenheit.
That's 131 degrees. It's only been about 2 minutes. So as you can see over here, we're at 2 minutes 30 seconds almost. Well, I don't know what about you guys. In the water over here, that is already starting to bubble. It's only been 3 minutes. Let's get a quick temperature gauge. Let's get a quick temperature gauge on this. This is already 75 degrees, let's call it, a minute ago. 75 degrees. Okay, Google, what is 75 degrees Celsius in Fahrenheit?
75 degrees Celsius is equal to 167 degrees Fahrenheit.
We're at 167 degrees Fahrenheit. And let's do a quick comparison. How cold is it on the outside here? This is cold to the touch. As I move closer and closer to the pot, it's 30 degrees. But look how close I am touching. It's cool to the touch. It's not even hot. Oh, by the way, it's been 3 minutes and 45 seconds. It's 4 minutes and it's 90 degrees. It's 4 minutes. I'm going to call that boiling, rapid boiling, whatever you want to call it. I'll pause it here. 4 minutes, 4 seconds to boil 1 liter of water. And here's the secret. Or here's the trick. When I lift off the pot, look what I'm doing, folks. I'm actually touching the device. I mean, it's warm. I'll have to stop it here because there's no pot here. But guys, this is induction cooking for you. The surface might be a little warm, but I can actually touch it without burning my hands. Quick temperature check. This is 100 degrees Celsius. That is the same temperature of the water, I suspect, there, or pretty close to it. This water is at 93 degrees. And I've taken it off the heat. 93 degrees. This top is about 100, see if it settles. Let's call it about 107 degrees. 107. But it's not hot. It's hot in the center where the temperature has transferred into the pot, but all around it, it's warm, but not burning hot. It's not 600, 700, 800 degrees. Now, the beauty of this is, should something ever spill over onto it, like this water, you notice how it's not immediately evaporating? I could wipe this off. And I could continue cooking without burning. Imagine this when you have a burn over. Imagine this when you have potato starch coming over it, or you've got splatter of sauces. You know what I'm talking about. It's a mess to clean up. You can't wipe it off because it would burn your cloth. Even if you put liquids on it, you couldn't really burn it off. Now keep in mind with this, don't forget folks, this is already cool to the touch. Whereas if I did it on a stovetop, it would take forever to cool down. This just takes a few minutes to cool. So it's much safer, it's much more efficient. Let's do the same test, but with the original stovetop. Alright folks, another reason why you want to think about using an induction cooktop. This is steaming away. Yeah, it's really steaming away. Just steaming some corn. And for experiment part 2, this is nothing but regular paper towel. All I'm gonna do, you would not think about doing this at all with your regular cooktop, would you? You would not. So what happens if I did this? That's right. I am going to, lift this underneath and put it underneath the pot. You see that? Do you see that? I'm going to get in closer. You would not think about doing this, and by the way, this is still on. In fact, I can crank it even higher. Because it's already boiling. You can see the water boiling down there. Oops. And underneath, ow! That steam is hot. Underneath, this paper is fine. That's still hot. It's still boiling. It's still boiling. So, do you think the energy efficiency of an induction top cooker is better than a regular stove? You bet. For our second part, we're gonna just use our regular stove here and our big burners. So that is a big burner here, as opposed to the little guy, which obviously fills the pot. This does not fill the pot, because that's really big. This one, well, unfortunately, is the small burner. This is the big 9-inch burner. I'm going to use this because this is going to demonstrate the amount of heat used to heat a standard electric stovetop. Now, just to set everything for the record, this is cold. This is cold. It's not preheated or anything like that. I'm going to turn on my meter. Scan the pot. I don't know if you can see that. I don't think anybody can see that. There we go. About 74 degrees. My measuring cup, 73.2. And just pure old water. So we got an absolutely freezing cold stove. We've got our temperature. How about room temperature? How about 75 degrees, give or take? We got water. Yeah, and room temperature. It's about 72 and change. Cold water. Got a cup. Haven't heated it, haven't done anything. Just want to make sure. About 74 degrees. So, let's get 2 cups of water into this. Oops, a little bit more. 2 cups. Another 2 cups. And just a little shy. So there is 4 cups of water. Guess that'd qualifies as a gallon. We are here in my control area here. Oh, that's not my tablet. Alright, so we've got that. Temperature. About 72 degrees. So everything is copacetic. I'm gonna go and now immediately turn on to max. I'm immediately gonna turn on my start timer. It'll be in the full view. I'm gonna see how long it takes to boil this water. Now this is a regular stove, conventional glass top. Alright, let's have a look. I don't want to get this timer too close because it is a really hot element. As you can see, let me just turn off the light here. Oops. You can see the light starting to glow immediately. So this is a conventional burner. Turn my light back on. It's been 30 seconds. I am going to measure this every minute or so. The temperature hasn't changed. I haven't touched the heat. I'll zoom in a little bit more. I don't want to get it any closer, but I will try to squeeze that into the picture frame. Here, that's what I'll do, is put it over here. There we go. And I want to make sure I can get some bubbles there. So it's been a minute. Oh, it's got a temperature. The water has only risen to 83 degrees. That's it. Now, conversely, let's look at the heat of this. Yikes, I can feel it. The ground here, or the stovetop, is around 500 degrees. Oops, sorry. Try that again. It's almost 500 degrees. 395. Okay, 350. But that's quite a bit of difference from the electric. I can just stick my hand here and I can feel the heat coming off. And it's only been almost 2 minutes. I'm going to start taking another measurement of the water. Zoom back out so you guys can see the results. I haven't touched anything. And you guys know this is boiling hot. This is the max of this element on a conventional. Oops, 2 minutes, I'm late. This water is only 112 degrees. It's already been 2 minutes. By this time on the induction top, you know what happened. It was almost near boiling. We're not even halfway there yet. Okay, I see a few whispers of. If you see a few whispers of the water, you can see that here. A few whispers of water starting to heat up. It's almost 3 minutes. Let me check the temperature here. The core temperature is 615 degrees, 615 on the front element. And in here in 3 minutes, the water is 136 degrees only. That's it. We are absolutely using a lot of energy, a lot of heat. And a lot of that heat is just being wasted. I definitely can't even get close to it. It's pretty hot. Small bubbles are forming in the water. And we're at 3 minutes and 30 seconds. Checking the water. It's barely moved very much. It's 150. We still got a ways to go for boiling. Now here's my point. If you guys had a boil over right now, here's 4 minutes, just to triple tap the water. 155 degrees. The surface temperature here, oh my god. Can you guys see how red that is down there? Ouch. Are you seeing some of these numbers? Oops. That surface is 850 degrees. You can't touch 850 degrees. Okay, it's starting to boil up pretty good. There's lots of bubbles starting. But temperature-wise, I haven't gotten to 200 yet. We are at 185, 189, 190. Alright, you know what, guys? Let's... It's not a rolling boil, but it is boiling-ish. It's got some small boils to it. There we go. Let's just call it there. I'm gonna stop it there. So let's call it 5 minutes and 6 seconds to boil 4 cups of water, or I guess a gallon of water, or half a gallon of water. Here, we just got to 200. We just got to 200 degrees roughly by these inaccurate, but close enough. 200 degrees. And officially I think water boils at about 212-ish. And here's 212. So I'm going to turn this off. Ouch. That's a lot of energy wasted. Now, I've shut, as you can see, I've shut off. That's a rolling boil. I should have stopped the video or stopped the timer here. That was at least another 30 seconds or more before this is completely a rolling boil. This table here, once I turned off the heat, is 708 degrees. There's no way I'm touching that. There's no way I'm touching that. That is super hot. What a waste of energy. If I put this pot to stop boiling, if I put it back down, look at that. That is beginning to reboil again. That is insane. Don't try this at home. Here's a plain piece of paper. Here's a plain piece of paper on this hot, and I don't know if you can see that, but that's starting to burn the paper. I'm proving a point that this is a super hot and waste of energy. Even though the electricity is off, I've turned off the element. This is so hot, it's hot enough to brown the paper. And that you can see. I can show you that by turning off the light. There you go. That burnt the paper. That's how hot this was. And if I put the pot back on, there's still enough residual heat being wasted because this surface is super hot. Induction top cooker, I would highly recommend as an efficient way, a much more efficient way of cooking food, saving energy, and cutting time. Folks, if you like this video, please hit the like button, hit the subscribe button for more Newbie Views video reviews, and we will see you on the next video.